This video will be an introduction on how to use your Unreal Engine project. In this video, I will use our default Unreal Engine project, which is free to download for anyone to use, but should be very similar if we created a custom project for you. When you download your project, your file structure should be very similar as seen here, with various names depending on the name of your project. The first time you download your project, Windows may block it as a security feature, preventing this from launching. All you need to do is right click, go into the properties menu, and there should be a checkbox down here to select unblock. You can hit OK, and now your project should open up just fine. The current version of the Unreal projects utilize this UDP format. This is the information that it expects from an outside source to visualize the flight simulation. I'll show later how to connect MAVRIK to visualize your flights, but you can use any outside code to interface with these Unreal Engine projects. These projects expect 33 doubles. It's important that they are the double data type instead of floats. And these assume the traditional aircraft coordinate system with X out the nose, Y out the right wing, and Z down. First, we have time in seconds, then 3 body velocity components, UV and W, body angular rates, degrees per second, the position of the vehicle starting at, normally these would start at 0 at the beginning of the sim, and Z is negative altitude because these align with our coordinate system. The next 4 are the attitude quaternion. These are generated using the yaw, pitch, roll rotation sequence. The next 3 are geographic coordinates, latitude, longitude, and altitude. And the remaining data fields are the commands. So there are 16 channels here. Most vehicles will only use the first couple, such as aileron, elevator, rudder, and a motor command. But the current implementation can cover much more complex vehicles. If you're integrating an external code with these Unreal Engine projects, make sure to consult the most recent version of this UDP format. Let's look how to connect MAVRIK to our Unreal Engine projects. MAVRIK has the UDP format automatically built in, and all we need to do is open the connections.json input file for MAVRIK and add a new connection. So all we need is this highlighted portion. You can copy this exactly as I have here, and it should connect to your project. This tells MAVRIK to send the information over UDP on port 9000. You can switch this if you need. Just make sure your Unreal project has the same change in setting, which I'll show here in a minute. It sends it at a refresh rate of 50, and we tell it what data type to use and to use double precision, which is important. So once you have this in your connection file for MAVRIK, you should be good to go. Now let's actually look at our project. So go to your project file and double click your executable. You should be brought to a main menu screen where we have a start button, which will put you into the level, an options menu, and a quit, which will close the application. Let's look at our option menu. These settings will depend on what functionality is built into your project, but we have a communications port. Make sure this matches whatever UDP port your external code is sending through. For MAVRIK, make sure this is the same. If you have a heads-up display built in, this will toggle whether or not that HUD displays by default. More than likely, you'll have multiple vehicles in your project. You can choose what vehicle you select here. You'll also more than likely have 2 maps, one being the Cesium world, which is the accurate Google Earth terrain, and the second a default map, which is a simplified map that's more or less a flat world. There are benefits to each of these. Cesium is more intensive on your computer and often requires the internet. So in cases where that's an issue, just use the default map. We have a graphics settings menu. Here we have 4 main options: a screen mode, a display resolution, a render resolution, and a texture quality. Unreal Engine can be pretty demanding on your computer if you have these settings at their maximum value. So if your computer is struggling a bit, then look at adjusting these parameters here. Full screen will open up the application covering the whole window. If you select the windowed mode and have a display resolution smaller than your max value, and hit apply, it will window the application and change the aspect ratio of the application. This display resolution will include all of the possible resolutions for your system, but some of these can squish the image here. So depending on your computer, choose one that maintains a good aspect ratio for the overall image, such as this one here. If you have the full screen mode selected, then decreasing display resolution will make the overall resolution more pixely here. But if it's in the windowed mode, then it'll decrease the size of the window. I'll put this back to maximum. These last two will have less dramatic effects to the visualization, but are some extra parameters if your computer is really struggling. So we can change the render resolution here and texture quality, but you can leave these at the maximums for as a default. You can hit apply and go back. Next, we have the world settings. So depending on what map you have selected here, will display what settings are available for that map. For the default map, we can specify the initial state of the vehicle. This is how the vehicle spawns in before it receives information from the outside sim. You can choose the altitude, the heading, and also the ground altitude. So this default map will put the ground wherever you specify here. So make sure this corresponds to the ground altitude in your sim. There's a parameter in the input file for MAVRIK, so make sure this matches that. Here we have a lighting setting for the sun elevation. The sun is oriented along the east-west line, so setting a smaller number such as 5 here will be a sunrise, and a larger number close to 180 is a sunset. You can hit apply on those. Let's look at the settings for the Cesium world. Cesium is an open Earth map, so specifying any latitude, longitude will put that vehicle at that location on the Earth. We have the same altitude and heading parameter we saw before, and we have some additional lighting settings. The Cesium sun will align itself with these parameters, creating a more realistic sun for that location and time of the year. Now apply and go back. The last menu here is the key bindings. Depending on the functionality of your project, there may be more or less of these. C typically maps to changing your camera view. H toggles the heads up display if you have one. The tab and escape keys will exit to the main menu. And if you're in any of these main menus, if you hit R, it will reset to default settings. I'll talk about that here in a minute. F11 will toggle between full screen or window. This is in addition to the previous graphic settings we saw before. If you hit F11 in full screen mode, then it will maximize the resolution in that smaller window. So use this as a convenient way to toggle between the two, but for a long-term solution, use the other graphic setting we showed before. Lastly, F3 will toggle a debug window. So when you're in the level, if you hit F3, it will show an overlay of the information that it receives from the simulator. Let's talk about how settings are saved. Any settings in any of these menus that are modified will automatically be saved when you hit the start button. So on subsequent loads of this application, they will load those settings so you don't have to modify. Let's say you choose a different starting location. You don't have to put in those coordinates every time you launch this application. If for some reason you messed up the settings and want the default settings, all you have to do is hit R. That will apply the default settings. So for example, if I change some of the default settings here, hit apply, hit R, it will restore the default settings back. All right, let's look at an example. I'll go into options. I'll select Cessna and default for now, hit apply and start. And we can see our default map here, which is just a basic flat floor with some basic terrain. We can hit H to toggle our HUD off and on, C for our different camera views, and F3 will show our debug menu. The sun is in the way a little bit here, but we can see we're starting at 4,200 feet at a heading angle of -50. The geographic coordinates, latitude and longitude, don't do anything in this level. This level is based off of position, so X, Y, and Z, and we have no commands right now. Let's go back and we'll change the Reaper drone HUD default to off. Let's go into the world settings and let's set the ground altitude to 0 and my altitude to 200 feet. Heading, let's put the heading at 90 in the east direction and put the sun elevation to 5 so we're pointed right into the sunrise. Apply. Here we have our Reaper drone, our different camera views. You can see the HUD defaulted to off, but I can still turn it on and off. Still have the debug menu, and we can see that it put the vehicle 200 feet in the air. If we come back here and set altitude to 10 feet, then we're much closer to the ground. If we change let's go up to 100 feet, but put the ground altitude at 90, this should look exactly the same, which it does. So make sure that ground altitude matches to what your sim is running. So make sure MAVRIK has that same value that you're expecting. Now let's try the Cesium map. I'm going to restore the default settings just for convenience. Go back to the quadcopter, Cesium world, and then I'll use the default settings for now. And depending on your computer performance, your internet speed, and the resolution you set will change how fast this terrain loads in. If it's taking a while to render in, try lowering your resolution in the settings menu. So here we loaded in our terrain. We're at the Salt Lake City airport. We still have our different camera views. We can toggle our HUD. And now we're spawned at a different location at a different altitude. So let's go back and mess with some settings. Let's try going to Miami in Florida. An easy way to get coordinates is to pull up Google Maps and right click, and you'll get the location here. Click that and it'll copy to your clipboard. Then you can open up a notepad and paste that in. And now we'll copy these into Unreal Engine. I'll put the altitude just at 500 feet. I'll also change the time zone. Hit apply. Now we're in Miami. So this just spawns the vehicle at this location. Make sure your simulator is sending the location you want as well. So if we open up the debug panel, it shows that we're at the correct location, but as soon as it receives information such as from MAVRIK, it'll overwrite that from the data that it receives. All right, let's actually run a simulation. I'm going to go into options, turn off the HUD. I'll select the Reaper drone and the Cesium world, and I'll leave everything else as default. I've spawned the vehicle here at the Salt Lake City airport, but I'm going to run MAVRIK out at the location of the Misty Way RC Park out in Grantsville, Utah. So you can see what happens when I start MAVRIK at a different location than the visualizer is at. You can see once I start that, Unreal Engine will update to the location that MAVRIK is sending. Let's enable the debug menu. So now we can see the different commands that are coming through from MAVRIK in this pre-launch state, and it'll launch here in a second. There it goes. And now I'm flying around. If you have a custom vehicle, it'll be pretty close to this Reaper drone unless we do extra work for you. So if I roll, we can see our ailerons moving and our V-tail moving around, as well as the propeller. This is just a very simple propeller model here. And I can fly around with our vehicle, turn off the debugging states. And I have the ground altitude in MAVRIK set close to this terrain here. So it won't be perfect because this terrain isn't perfectly flat, and MAVRIK is assuming the ground is flat. So if we fly towards the ground, MAVRIK should stop. But this version of Unreal isn't sending any collision data back to MAVRIK. That's a future implementation. So you can actually fly through the terrain, through the mountains. So set your ground altitude appropriately. If at any time you get stuck or your vehicle goes through the ground, all you have to do is hit tab or escape, go back to the main menu and hit start again, and it'll load in your vehicle at the initial location. When I'm running simulations, I'll just leave Unreal Engine open and I can start and stop MAVRIK anytime I need to. So you don't need to close and reopen this Unreal Engine project every time you restart a simulation. So this has been a quick introduction on how to use your Unreal Engine project. The project I've been using in this video is a default project, which is free for anyone to download. To give you a taste of what Unreal Engine is like, we build custom projects for our clients, including implementing custom terrain, putting in their specific vehicle, and doing all of the animations so that the control surfaces move in flight, including transition vehicles or morphing aircraft. We also design custom heads-up displays and camera views, trying to emulate as close as we can the actual mission the aircraft will be seeing, including gimbals and FPV cameras. So for more information about that, along with our other software packages such as MAVRIK and our Unreal Engine projects, be sure to go to our website. A link is in the description, which is falconaerospace.us. If you have any questions or find any bugs in your project, be sure to reach out. Thanks for watching, and I hope you have a great day.